Hey everyone, welcome to my channel. So in this video I'm going to try to solve this question. At the same time, I'm going to try to follow the general interview steps while trying to solve this problem. So let's get started. First of all, let's try to get a good understanding about the question. So for a binary tree T, we can define a flip operation as follows. We can choose any node and swap the left and right child subtrees. So binary tree X is flip equivalent to a binary tree Y if and only if we can make X equal to Y after some number of flip operations. So given the roots of two binary trees, root 1 and root 2, we are going to return true if the two trees are flip equivalent or false otherwise. Alright, so let's see this one. We have two of the trees, something like this. We are returning true because we could flip the nodes with value 1, 3, 5. So let's say if we flip nodes with 1, that is going to swap the two subtrees. Then we do the flip for node 3, then we are going to change the 6 to be the left from the left subtree to the right subtree. And then we change 5, we are going to change the 7, 8. Okay, so after the 3 flips, then we are going to have the two trees as equivalent. Now that makes sense. And similarly, we have if two roots are both empty trees, then we return true. If one is non-empty tree and the other one is empty tree, then it's going to return false. Alright, so I think it makes sense overall. Let's see the constraints. So the number of the nodes in each tree is in the range of 0 to 100, and each tree will have unique node value in the range of 0 to 99. So each tree will have unique node values in the range of, I think it seems like this one is indicating that each node has different value. And also this one indicates that it could be empty tree as the input for the input parameters. Alright, so I think some edge cases worth to think about is, like, for example, empty tree for the input parameters. For this constraints, which says like each node has different value, I think it's going to give us some pretty strong constraints. So having said that, the only edge case I can think about is the empty tree. But actually, if we write our logic in the succinct way, I think we can generally cover the empty case, the empty tree case in our general implementation. So after getting understanding about the question, the next step is for us to try to find a solution. So for this one, it seems to be a pretty traditional DFS question or recursion question. What we could do is we could call recursive function. Like, this is already well-defined function. We either try to see if there are two ways. So first of all, we can see, okay, the current tree is equal to the root 1 is equal to root 2. The two trees are the same. Or we could try to flip the we could try to flip the left and right tree for root 1 and see if after the flip is going to be equivalent. But as I said, it's going to be like a recursive function. So what I'm trying to say is it could be root 1 dot left and root 2 dot left, and similarly, so and flip equivalent root 1 dot right and root 2 dot right. So suppose the root value, the value of root 1 and root 2, they are the same, then we have two choices: whether the left subtree and the right subtree are flip equivalent, and the right subtree and the right subtree for the two of the roots are equivalent. Or the other case is we could try to make sure if the left subtree for root 1 is flip equivalent with root 2, the right subtree of root 2, and also at the same time root 1 dot left is flip equivalent with root 2 dot left. So there are two other ways, so either way should work. So if one way works, then we can call it flip equivalent for the entire tree. So that's why we add a OR condition here. So that's pretty much about the DFS function. So the runtime is not very clear to me, but I think I remember some general ways to calculate the runtime for this kind of recursive function, but I kind of forgot that. So it seems to me to be linear runtime. So let's say suppose root 1 has n nodes, root 2 has m nodes. So it's something like n, or the minimum of m and n. Because we are doing the it seems to be like we are doing the comparison for each of the node constant times. But like I said, I think there could be some other answers if I get it wrong. So if you have a better idea about the runtime, feel free to leave some comments below actually. So let's try to do some coding work on top of this solution. So the first thing we need to check is it's a recursive function, which means we need to define.
I found this on the web.
Whoops. Like Siri is not doing a right thing. So if the root 1 is equal to root 2, which means they are the same tree, then we're just going to return true. This is the exit for the recursive function. Otherwise, it means root 1 is not equal to root 2. So like I said, it could be a non-pointer. So in this case, since root 1 is not equal to root 2, if root 1 is equal to a non-pointer, or root 2 is equal to a non-pointer, or root 1, so if root 1, this condition means root 1 is not none and root 2 is not none. That is because the compiler for Java, if root 1 is equal to none, then it is going to be true. Then we are not going to evaluate the rest of the things. So here it's safe for us to write the thing like this: if root 1 dot value is not equal to root 2 dot, well, okay, so this is wrong. If that happens, we are just going to return false, because this means root 1 is none but root 2 is not none. This means root 2 is none, root 1 is not none. This means both root 1, root 2 are not none, but they don't have equivalent value for the root node. So if that happens, we are just going to return false. Otherwise, we just call the condition we defined above, which is we have two choices. We either have the left right to be equivalent, or left right left to be equivalent. Alright, so let me write it in a better way. Alright, so I think that's pretty much it for the logic. I rely on this platform to help us to do the debugging work for us. So it seems to be working, and there's some other things. Let's do a summation for it. Alright, so actually everything works well. So that's pretty much it for this question. So if you like this video, please help subscribe this channel. If you have any question, feel free to leave some comments below. I'll see you next time. Thanks for watching.